Where is it? Yeah, it says find the Taylor series. I think it's problem 6. Find the Taylor series for f of x equals natural log of 1 plus 3x about x equals 0. By taking derivatives. And okay, they also say find the interval of convergence. Okay, well, I'm going to start out by saying, heck, what do I want to say? I even had a word for it. Question authority. Okay, WeBWorK is the authority, but I'm going to say, wow, let's not take derivatives. I'm going to do that for you in a minute, but let's just find the Taylor series. What if I just put the period here? This is going to take like less than a minute to do after you know what to do. And then by taking derivatives, it's going to take a long time. But anyway, all right, okay, cool. So we've already got the Taylor series for log of 1 plus x about x equals 0. I can see because there's no x minus a. All right. So I just substitute in 3x for that. So I get natural log of 1 plus 3x is going to be sum from n is 1 to infinity of minus 1 to the n plus 1 times 3x all to the n over n. Okay? So that's actually the answer that WeBWorK wants for this problem. Actually, I got it wrong the first time because I forgot to put the minus 1 in parentheses, right? I want to take the whole minus 1 raised to the n plus 1. That's different from minus 1 to the n plus 1, which is always minus 1, right? Let me just write that. Right, minus 1 to the n plus 1 is not equal to minus 1 to the n plus 1. Because that, right? Because minus 1 to the n plus 1 is minus of 1 to the n plus 1 is minus 1, right? Order of operations. Okay. So, okay, this thing which converges. So let's think about the interval of convergence. This series converges for, well, the series with just 1 plus x converges for minus 1 less than x less than or equal to 1, but I'm replacing x by 3x everywhere, including there. So I get, and this becomes divided through by 3, I get minus a third less than x, less than or equal to a third. All right. Cool. So let's now actually do what they told us to do. Let's actually reproduce this result by taking derivatives. And then actually, you can't even prove the interval of convergence by, you'd have to, they just actually tell you to guess it. So so let's just try to do the first part by taking derivatives. Okay, all right. This video is not going to be as quick as I had hoped, but all right. Okay. So I'm going to say, find the Taylor series of that. I'm going to say, using, basically we're going to be using that Cn is the nth derivative at f evaluated at 0 over n factorial, right? All right, so I'm going to need to make a table for this. So we're going to do a few turns. We're going to take the derivative a few times. All right. So what is the original function? Is natural log of 1 plus 3x. Okay. The first derivative is 1 over 1 plus 3x times 3 from the chain rule. I'm going to write this as 3 times 1 plus 3x to the minus 1. I differentiate twice, differentiate that, I get minus 3 times 1 plus 3x to the minus 2. All times 3 from the chain rule, that's going to be minus 3 squared times 1 plus 3x to the minus 2. The next derivative is minus 3 squared times minus 2 times 1 plus 3x to the minus 3 times 3 from the chain rule. And let's put that in. There's two minuses, so this is plus 3, okay. 3 squared times 3 plus 3 cubed, right, times 2 times 1 plus 3x to the minus 3. All right, so here was, hello, here's another hopefully short video to finish up this problem of finding the Taylor series by differentiating, and we're going to use that formula for Cn. So what I've done here is I've done a lot of the work of differentiating this function log of 1 plus 3x. I've done it, found the derivative 6 times. And then I'm going to evaluate all of these at 0 and then find Cn. All right, so one of the nice things about these derivatives is when I evaluate these at x equals 0, the 1 plus 3 times 0 to any negative power is 1. So I can just ignore that part. So what do I get here? I get f of 0 is log of 1, which is 0. The first derivative is 3. The second derivative is minus 3 squared. The third derivative is 3 cubed times 2. Fourth derivative is minus 3 to the 4th times 2 times 3. Fifth derivative is 3 to the 5th times 2 times 3 times 4. Sixth derivative is minus 3 to the 6th times 2 times 3 times 4 times 5. Okay? All right. So now let's figure out what the coefficients Cn in the Taylor series are. Well, 0 over 0 factorial, that's 0. So that's 3 over 1. And then I get minus 3 squared over 2 factorial, that's minus 3 squared over 2. And then I have 3 cubed times 2 over 3 factorial. That gives me 3 cubed over 3, because 2 over 3 factorial is just 1 over 3. Then I have minus 3 to the 4th times 2 times 3 all over 4 factorial. Well, 4 factorial is 2 times 3 times 4, so I get minus 3 to the 4th over 4, right? And then I get plus 3 to the 5th times 2 times 3 times 4 all over 5 factorial. 5 factorial is 2 times 3 times 4 times 5, so I'm just left with 3 to the 5th over 5. Okay, this one I get minus 3 to the 6 times 2 times 3 times 4 times 5 over 6 factorial. That's just minus 3 to the 6 over 6. So clearly, or just kind of guess or whatever, you see the pattern. Cn is, well, it's a plus or minus, and when n is odd, it's plus, so this has got to be n plus 1. And then I have 3 to the n, right? I got C2 has 3 squared, C3 has 3 cubes, 3 4, 3 fifth. And then what's the denominator? Just n. Okay, so I have reproduced what we got in, like, it took as long as it took me to just write down the answer before using the known series for log of 1 plus x. Doing all this work, we can reproduce the coefficient Cn in the Taylor series, right? F of x is sum from n is 1 to infinity of x to Cn times x to the n, right? And there's a little bit of a funny thing. I don't start with n equals 0 to infinity because C0 is 0. But you notice that I can't plug in n equals 0 in this formula. It doesn't make sense if I plug in n equals 0. So I have to start with n equals 1. It's a little subtlety. All right. So good. Thank you for watching this. If you did watch this, I should give you a special bonus. I'll give you like what's the code word? Like COVID-20. COVID-20. Okay, so if you tell me COVID-20, send me an email. I'll give you an extra credit point for watching this. Okay. All right. Bye.